Hello, and welcome everyone. We appreciate all of you taking time and joining us today for XNT302, build, test, and deploy your .NET applications on AWS. For those of you who are planning to watch this later on demand, we want to welcome you as well. I'm Jagdish Chitikesi. I'm a senior Microsoft specialist architect at AWS, also joined by my colleague, Draw Helper, who will be presenting later in the presentation. He's a fellow senior Microsoft specialist solutions architect on AWS as well. We work with customers like you to help them migrate and modernize .NET applications on AWS. All right, let's get started. I want to walk everyone through a fairly typical scenario that we see in greenfield projects, right? So these are brand new, start from scratch projects. So you usually don't have the constraints, the business constraints, or the constraints posed by the existing code that you generally see in a brownfield or an existing project, right? So as .NET developers, it's very exciting. You don't get a lot of chances to work on such projects. The biggest advantage when you're doing that, when you're working with a greenfield project, you have a well-defined scope as a starting point. Now, you take that scope, and then you build your rockstar team of .NET developers, software architects, project managers, agile team, and you start taking a crack at the project, right, or the product. You start developing all the features incrementally until you reach the finish line. And then, assuming you did all the right things, you hit the day of the launch. It's time to show the world what you've built, or also pray that nothing breaks, right? It happens. The next thing is far from guaranteed, but assuming that you had the right product idea and you executed really well, you will end up seeing that your customers actually like your project. That's a happy ending, but it's not the end of the story, right? Is it? So I've worked in IT for over 20 years, and I can confidently say that's not the end of the story, right? So as customers adopt your product more, they would have feedback. They would tell you the good, the bad, the ugly of the project, right? So if you're customer obsessed like we are at Amazon, what you want to do is gather all of that feedback, document it, analyze it, and then let that dictate your product roadmap. So use that to build your product backlog. But now you're not operating off of a well-defined scope anymore, right? So you have multiple priorities for your development team. You still have a list of features that you want to develop, right? So you still there are bugs being reported by the customers that needs to be fixed. As with any project, you constantly work on application performance, security enhancements. Also, remember, we're talking in the context of .NET world, so there's a new version of .NET that's released by Microsoft every year. And then it's not uncommon for a lot of our customers to spend or to allocate some dev cycles to make sure that they're refactoring their .NET applications to the latest version every year. So that takes some time as well. So if you're not prepared enough with this change in focus and priorities, it's natural that you see a decline in your team's productivity, right? So not enough features being developed, code quality might go down, code freeze windows increase before release, missed deadlines. Eventually, your developers may feel the burnout, which may eventually lead to one thing that no one wants, right? Unhappy customers.
Right, and the solution is to add more developers because that's the simplest thing we can do, right?
Yes. It's very natural for a lot of project managers, especially also customers that I work with, to think that adding more developers would solve the issue. Definitely not the first thing that you may want to try, right? So I want to bring up something a quotation from a book from Fred Brooks, The Mythical Man Month from 1975. Now, you wouldn't expect a 47-year-old book to still be relevant to this day, but a lot of things that Fred Brooks said and practiced in his career still resonate with a lot of software creators and designers today. Right? So Fred Brooks notes that adding manpower to a late software project makes it later. Right? So imagine a team of 10 is tasked to deliver a software project in a year. Would a team of 20 be able to deliver it within half a year? I mean, this probably works for projects that scale linearly, but it wouldn't apply for software development, right? So I mean, don't get me wrong. There are plenty of situations where adding more developers to your team is the right solution. is the right way to go. But your focus should always be trying to achieve more with less, with the modern tools and processes. Right? So more innovation, more speed, more security, more agility with less cost, less resources, less time, less errors, and so on. So it's easy for me to say, right? But yeah, it's easier said than done, no doubt. There's a little bit of work involved, right? But there could be other things, but we fundamentally believe that if we take all the undifferentiated work from your team, right, and focus on activities that provide value to your end customer, combine that with the fact that there's a mechanism to provide faster feedback loop to your developers, right? So when things break, and let's accept it, things break all the time. So just make sure that with the right metrics and data goes to the developers to make sure that they could go in, fix things quickly. So fundamentally, we believe if we are able to achieve these two things, it will improve your time to market and also your code quality ultimately. So this is where CI/CD comes in. I do not want to define CI/CD. I'm more than sure that all of you know what CI/CD is. So yeah, these kind of practices help your developers to commit more frequently, catch errors more quickly, deploy to production more frequently, and also adopt automation at different stages, right? So there are different stages in the process. The focus of this presentation is going to be on source, build, test, and deploy. As you all know, there are other stages like security that are supremely important, but the focus of this presentation is just going to be on the stages that you see on the screen. So the rest of this presentation, what we're going to do is share best practices along with the right tooling that you could use at these stages to improve your team's productivity. Also remember, this is not a one-time thing. Probably all of you saw the infinity symbol that CI/CD uses. So you are expected to use these stages or follow this process throughout your development lifecycle. So, but first, I want to show some market research, right? So, what are some of the high-performing companies from around the world are able to achieve by basically using these practices? It'll also tell you why you should invest your time and your team's time into this. So, first one is these companies are able to bring down the deployment frequency to basically on demand, right? So, which could translate to multiple production deployments a day. Also, you don't have to schedule like midnight releases where operations and developers come together and then just hope they get to go back home by 1 a.m., right? The lead time for changes, which is a metric that's calculated by looking at the time from a code committed to code successfully deployed to production, is less than 1 hour. Time to restore a service that is undergoing an unplanned outage is again less than an hour. A production deployment that ended up in service degradation is less than 15%. So it's incredible, isn't it? So what some of these high-performing companies are able to achieve using these CI/CD practices. Right, so let's look at some of the practices at each of these stages that'll help you get there. Right? So also remember, it's a combination of using the best practices and also the right tooling that applies for your team. So let's start with the .NET code. What can you do at your .NET code? There are several things, like traditionally developers not used to committing code frequently. They would wait days, weeks until they finish working on a feature. Get into the habit of committing code more frequently, right? So it also helps in identifying issues early. Have a good code review structure in place. Now, there could be developers that are very possessive about their code and may not take feedback in the right way, but this is proven to help your teams get better over time. Learn from each other. Run unit tests before you commit your code. Have gated check-ins before you try to merge your code, not affect every other developers on the team. Also have right notifications for visibility, so everybody on the team knows what's going on. Now, it's also important to use the right tooling, right? So there are tools and SDKs AWS provides when you're developing .NET code against AWS services. So we have toolkits that plug into your IDE directly. You're seeing familiar IDEs, Visual Studio Code, and JetBrains Rider. These toolkits help you develop or interact with your AWS account without having to leave your IDEs. And we also provide programmable SDKs, software development kits, that help you program against AWS services. Right? So this helps you. They abstract away a lot of lines of code when you're interacting with AWS services. And they're available for both .NET as well as the older .NET framework. Now, once you have your code, you want to push it somewhere to collaborate with your wider team. So that's where AWS Code Commit comes in. It's a managed source control repo that helps you, they provide managed Git repositories, push your code, collaborate with the wider team. It's also important when you're talking about code to be able to use reusable constructs in your code. So these are typically NuGet packages that you want to build, publish, either internally, or if you have customers who use NuGet packages that you build, you can also push them externally. So AWS Code Artifact is a completely managed service and secure service that help you deploy and publish your NuGet packages of your .NET code. So to talk about build and deploy, I want to hand it over to Draw, but also just curious, why do we want to talk about build and deploy together and talk about test later?
Right, because the build and deploy are tightly coupled together. You can't have one without the other. This is the backbone of your entire development lifecycle. And with the proper build and deploy in place, automatic build and deploy, you can reduce the overhead for your developers. They can focus on writing code and not on packaging systems and deploying to multiple environments, and you also get that time shorter. And in order to have an effective build and deploy process, you need to follow 3 rules. First of which is every commit triggers a build. You don't want a daily build. You don't want to wait till for tomorrow morning to find out if what you just wrote works. You want it to be built and deployed and then pushed. And if something bad happens, that's perfectly fine. You want to know immediately. And then you want to fix it as soon as possible, because you don't want to wait to find out that you have a problem, and more people committed more and more code, and as time progresses, they lose trust in your build system. So you want to fix everything as soon as possible. It will increase your team's confidence and make the build more effective, and also show that you care about your coworkers and don't waste their time. And finally, you want to frequently commit as much as you can. Whenever you have new feature added, or a part of a feature added, and you haven't broken anything, well, that's fine. Why not commit it? Why not say build, merge it back into your code? Don't wait to the end of the month or even the end of the day, because then you'll have very painful merges, and if you have a problem, it's harder to track it down with a lot of changes on top of it. Now, in .NET, with build and deploy, it depends on 2 major things. What .NET runtime are we using, and what we want to deploy to? What's our target? So with .NET Framework, which is still being used, we are running on Windows, which means that we need to build everything and run our tests on a Windows machine. And while with .NET or .NET Core, if you use an older version, then we can use the multi-platform launcher and run on a Linux machine, because probably you're already using Docker there, and you want to build it on a Linux machine. Deployment in AWS for .NET can come in many shapes and sizes. You can deploy to virtual machines. Those virtual machines can run on EC2, Elastic Computing Cloud, virtual machines that can run your .NET code, or you can use AWS Elastic Beanstalk, which is a solution, a managed solution that helps you operate, deploy, and run website on top of AWS. So you don't need to worry about running IaaS and using web deploy. Or you can go containers, because that's what everybody does, right? And with containers, we have ECS, Elastic Container Service, and EKS, Elastic Kubernetes Service, where we can host our Dockerized application. Or you can use AWS App Runner that enable you to run and deploy and scale containers without needing any prior infrastructure or container and Docker knowledge. And the last option is, right, Lambda. We can go full serverless, run our code without worrying about the underlying infrastructure, get automatic scaling without needing to worry about it. Depending on our .NET runtime of choice, or not choice, forced, we can get to choose some of them. Because if we're using the Windows-based .NET framework, then we can use either virtual machines or Windows containers running on top of ECS and EKS that has Windows container support. Windows containers, if you don't know, are similar to Linux containers. They are bigger, take more time to load, but you still get the deployment benefits, scaling benefits, and orchestration benefits out of them. But if you use .NET, the new version, 5, 6, 7, or even prior, 3.1, then you can use every single of those options. And it's up to you to decide according to your project needs, your preferences, and your underlying architecture. Okay, so what does a build deploy look like? A very common scenario we tend to see with .NET shops is deploying to IaaS. We have an application, a web application, a service runs on top of IaaS. So the deployment pipeline should look something like this. We pull everything out of the source control, triggered by a code change, then run NuGet restore and build, depending on which .NET we have, and run our tests. We'll get there. And then we package and deploy. And those two depends on our target. If, for example, I want to deploy to IaaS running on top of EC2 systems, then package and deploy are probably publishing your website either directly to IaaS or publishing to a package and then using web deploy to publish it to your website. On the other hand, if you're using Elastic Beanstalk, slightly different. We create a zip file and use AWS API in order to upload it to Elastic Beanstalk. The second most common case is using a containerized application, either Windows or Linux containers. And it starts the same, because in the end of the day, it's .NET code. You still need to compile it and build it and run tests. But then we get to build Docker. We get a Docker image out of it. And probably we want to scan it for known vulnerabilities. There are tools that you can install on your build agent or run a service, third party. You can also upload it to ECR, where it can be scanned as well. ECR is Elastic Container Registry. That's where we store the Docker images. And then we need to update our cluster in order to use the new container image. Now, 99% of the workload will fall under those two categories, and probably the rest will be Lambda. So we always have very similar build pipelines when we handle .NET, at least. It has some variety, but usually those steps. Which brings us to the tools, because unfortunately we can't run build on PowerPoint. And we have several options in AWS. First of all, we have the native AWS tools supporting .NET, code pipeline, code build, code deploy. All of those are fully managed. You don't need to worry about build agent, infrastructure, and you can run your workloads on top of them. Or if you're already using a build tool such as Jenkins or TeamCity or any other third-party application, you can host it on AWS. And finally, we can also use third-party services outside of AWS, Circle, CI, GitLab, according to what your organization currently using, and deploy to AWS using different methods.
It's great to have a lot of choice here, but it also brings a challenge, obvious challenge about how do you go about choosing the right tool for your game.
So how do you choose? There's so many options. First of all, according to what you already have and what you prefer to use, obviously. But once you do choose a tool, especially with .NET, you have to make sure that you get at least the following capabilities. If we talk in .NET, and most of our .NET clients run both .NET Framework, .NET Core, it means we need multiple environments. We need Windows, we need Linux, probably several flavors. So we want a build tool that can handle running both on Windows and on Linux, that can build .NET and use our tools of choice. And obviously, if we need Docker as well. We wanted to be, our build pipeline to be in code. All modern tools have the ability to save the description of your build pipeline in a file or files that you can later on save in your source control alongside with your project. You want to do that because you want to be able to deploy your project from a month ago from time to time, and build tend to change over time, and you don't want to configure everything on your build tool. You want everything to come with your code, so you get versioning and you get it side by side. And also, you want visibility, traceability, because everybody is optimistic in projects. But the reason we have a build tool is because it will fail from time to time. We want to be able to immediately know what the problem is. We want to know information about our build and what's the root cause of any failure. So whatever tool you use, make sure it can understand failures in .NET build tool and unit tests. If you're using NUnit, XUnit, MS Test, those things need to show in your build tool. And finally, you want statistics. Those statistics will help you fully understand the state of your build compared to last week, last month. Do we have more tests, less tests? Does the build take more or less time? What is the average time running the build? And does my coverage goes up or down over time? It's a nice to have thing, but your team will benefit from it. Yeah. So here is Code Pipeline. If you've never seen Code Pipeline, it's an orchestration tool that we use in order to run other AWS services like Code Build, Code Deploy, or even AWS Lambda. And Code Pipeline is split into different stages. And in this case, you can see it all starts with source, just like in the build pipeline. We have here build and then update pipeline, because the code pipeline itself is stored in my source control with my project. Whenever I change, it's the definition of what my build should be. I want it to immediately, automatically be updated here. I don't want to go to the AWS console to update it. Later on here, I build 2 services, that's 2 Docker images, and deploy to dev. And first I run my unit test to make sure that everything's okay, and create my infrastructure and deploy it to AWS. And this is basically a 2 services kind of project. And it's simple as that. But that's not good enough, right? We said traceability and statistics. So with Code Pipeline that fully understand the .NET tooling, we can look at what happened throughout the different runs. When you can see how many runs we had, what's my failure rate, how many reports I have, how many tests. And I can go and see the latest builds. And if one of them failed, like here, I can go in, and in this case, 41 tests just failed on me. So I wanted to test that. And I can go into a single test and see what was the problem. Now, that's AWS native tooling, which is nice. But you can also host your own, right? We can use Jenkins in TeamCity or any other build pipeline tool on AWS. But because we use AWS build tool, does not mean that we don't gain anything out of running in AWS. Because there are a lot of benefit of running a third-party application on AWS in the end of the day. Usually we have a controller. This is where we control the different builds, see the statistic, the information. And then we have a bunch of agents that run the build. Now, with AWS virtual machines, I can create a virtual machine, set up my environment on that virtual machine, create an image out of it, and then multiply that image by how many agents I want. And I get a consistent, duplicated environment to run all my builds on AWS. And yeah, since it's .NET, probably need Windows machines as well, so 2 groups. And that's nice. But usually, if I'm already running in here, I'm going to use AWS services. I might need to deploy to Elastic Beanstalk, or I want to get information out of Secret Manager, for example, my database connection string. So I'll use roles that enable me to get those virtual machines' ability to connect to other services without needing to pass password around or secret keys. And that's nice. That saves me a lot of time, this structure, but that's not good enough, right? It's not highly available. I don't want my developers to wait in case of an outage or if I don't have enough build machines to get them up and running. So I probably want to deploy another group in another availability zone and have all of those in auto-scaling group, because there's no point with build to keep a few hundred machines running, staying around, idling, waiting for a build to happen. I want a scaling group with a bunch of rules in order to make sure that I have just the right amount of machines up and running, so that if I have a huge load, huge CPU, a lot of builds, I'll add more virtual machines. If I have a little load, maybe it's a weekend, maybe go all the way down to 0. And that way I get a fully elastic, very efficient, and cost-effective solution with the same tools just running on AWS. And that's just one architecture. I can go full containers on it, because AWS Fargate, which enables me to run containers in a serverless manner, fits perfectly with builds that goes, run for a few minutes, and goes away. And I don't need to run those machines and keep them around. Although you might want to keep a few machines for things that take longer to start, for example, Windows containers. And then you have those groups according to what you need. And in the end of the day, your developers they just see Jenkins or whatever tools. And you see the build pipeline that deploys into ECS in this case. And you can see the state. And they don't care. They get everything up and running. Whenever they need to start a build, they'll get it automatically. They don't need to wait because you have a finite number of machines. And everybody's happy, right? And that's brings us to testing. And testing is the secret ingredient that will make sure that your build actually, you benefit from it. It actually works. You don't need to go back and fix things all the time. Because with testing, the first thing you get is very quick feedback. You run the build, and you immediately know the state and the quality and the health of your project. If a test fails, you have a problem. If a test doesn't fail, hopefully it means everything is OK. And by using tests, we get this quick feedback, and then we can quickly fix it instead of waiting for someone to tell us that there's a problem, a customer or a tester. And we get the regression immunity because I don't want to break yesterday's code by writing new features today. I want to be able to continue progressing forward and not moving backward. Now, it seems a bit counterintuitive, but tests will enable you to move faster. It's counterintuitive because when you think about it, simple addition. If you have only code, it takes less time to write than code plus tests. But if you just write code, there'll come a time, probably more often than not, that someone will come to you, tell you to stop working on the latest feature and fix a bug. And you need to go back, stop what you're doing, go back. Developers love that. And then go back again. And you keep on moving back and forth, and you waste time, essentially. You want to be able to move forward. And you need automatic tests that run as part of your build in order to achieve that effect. And testing, it's not complex, but it does require some experience using it. But let's say we have a Lambda function. A Lambda function is a simple, in this case, written in C#. This is only the partial code. You don't see the actual functionality. The function is written in the bottom, and I didn't write the code. It does not really matter. And that Lambda function will be triggered when a new file is saved on S3. And when a new file is saved on S3, the Lambda function will wake up magically, read that file, process it, and save the result in a database, in this case, DynamoDB. And that Lambda function, I want to test it, but I don't want other things like S3 and DynamoDB in my test, because that way my test won't be predictable, require external dependencies. And I don't think that you have a single account for each and every developer to run these tests. And you don't want to do that either way, because we want to focus on the logic. And the way to focus on the logic is to get away and throw away all the external dependencies. So the first thing we need to do is create dependency injection, essentially a constructor that gets all of the dependencies I don't want. In this case, clients to call S3 and DynamoDB, so I can replace them in my test. And the way to do it is I have a Lambda function. It's being triggered by S3. I don't want to trigger it by S3. I don't want to need to upload the file to AWS in order to see the Lambda function working. So I'll replace that with the test. Because the Lambda function is just a function, just code. Write new and run the function, and you're done. And the second thing I want to do is get away with the DynamoDB that I don't want to set up and run, and replace it with a fake DynamoDB. Now, the trick of doing that's very simple, because I'm not replacing DynamoDB. I'm just replacing a class that is called DynamoDB client. And the way to do it is to use a mocking framework that will inherit that class, and then replace it with a class that does absolutely nothing by overriding all the methods and giving them no implementation whatsoever unless I tell it otherwise. And the test will look something like this. This is a very simple, trivial test. The first test I will probably write. And in this case, I'm testing that if I get an event from S3 and I have a problem because the event did not have the information I need, I shouldn't write anything in my database. And it starts by creating two fake objects, a fake S3 client and a fake DynamoDB client. I'm using Fake It Easy, open source mocking framework for .NET. And once I have those two fake objects, they do absolutely nothing unless I tell them to do that in the context of the test. Then I can initialize my Lambda function, essentially write new, and then call the method. And in the end, I can check that no one has called the method on the DynamoDB client that saves something in the database. Now, this is a trivial test, but by writing a lot of those tests, or a few, not a lot in this case, a few, maybe 10, 12 tests, I can test all of the logic, all of the things inside the Lambda to make sure it does exactly what I want, right?
Hey, so let's see. So that was a very straightforward, but yet very useful case of how would you would test a serverless function like Lambda, right? But how about testing an ASP.NET application that has a little bit more layers to it, like an NTR application, for example? It has a bunch of external dependencies or different layers within the components that talk to each other. So how do you handle those situations?
Right. So yeah, real applications have multiple layers, probably some more than others, and we have external dependencies. We have databases, we have queues, we have other third-party services, other services if you write microservice architecture. And in that case, you probably need more than just unit tests. A unit test will test your business logic, and that's the test pyramid if you ever saw it. We'll start with unit tests, just like with the Lambda function. Take bits of my logic and test them using code, with code, the unit testing framework, mocking framework. Just test the internal and don't run any external dependency. But that's a problem, because I still need to check that my queries to my database actually behave like I expect them to. I still need to check that things that go outside the scope of my code work exactly as I want it, and fake them is not always a good idea. So I need something else. Integration tests essentially start whatever resource, whatever third-party application, whatever external dependency for real, and run your code against it. Now, if you're already using .NET, latest version, then you probably have Docker. So if you have a database that is easily set up, you can probably set it up inside Docker, run your tests, and then scrape it out. You can run Docker from code and do that. And then we go to service-level tests, the whole service, the whole monolith, the whole application, end-to-end, probably without external dependencies, other services or AWS services, to check that all my application work top to bottom with a few key scenarios. And then I need to fake things, but probably can't use a mocking framework. Because with service-level tests, I can run the service outside the scope of my test. I will execute it as a different thread, a different process. And then I can use different ways to fake things outside of my service. If it's external services, I can use the same idea like mocking framework with services. There are projects called mock server that will create a server, HTTP server, that I can command, tell it, when you get 1, 2, 3, 4, HTTP, whatever, return this result. And I can fake a whole service. I can also run the real dependency if I don't have any choice. And there's also local AWS services that you can run. They're not really local, but they mimic the real behavior of the real AWS service. For example, DynamoDB has DynamoDB local that you can run either from your code, outside of your code, or inside the Docker image, get a thing that understands and return results like a real DynamoDB that you can work against. And there's open source projects for many AWS services specifically for those kind of tests. Also a few commercial ones as well. And finally, there's end-to-end tests. Now, end-to-end tests usually look like the best way to start because it tests my whole application top to bottom. It's the perfect test. It does the right thing. The problem is that maintaining those is very hard. You need to set up your system. It will take a while. And if something changes and something breaks, you need to go into a very lengthy debug session to try to understand what went wrong there. That's why it's a pyramid. It's a pyramid because the higher I go, the less tests I have. Unit tests, you have a few hundred, a few thousand, then an order of magnitude less integration tests, only in the places it makes sense to really test the integration, not in every single point. Service level tests, a few key scenarios, end-to-end tests, only the important ones. Because the higher you go, the more time it will take to run the tests, and we wanted quick feedback. I want to know in 5 minutes or less if my project is healthy. I don't want to run end-to-end tests, each of them taking 15 minutes. 4 of those will take an hour. That's not something I can do. And they will break more than unit tests and are harder to maintain. Now, depending on the project, you might not need all of those kinds. We just saw Lambda function unit test probably will cover 90% of what you need, maybe 100. But the bigger the server you have, the more processing you do, the more integration you have, those different layers might look different. And that is usually the testing strategy, or a good place to start, or at least have in your head when you start to think about how to test your things. Now, we covered build, we covered source, build, deploy, and testing. So that's the end of the session. Thank you for coming, right? Done?
So I wish we did miss an important part of the whole build pipeline. Any guesses what that is? Right, it's infrastructure as code. So a quick show of hands, how many of you are aware of infrastructure as code or use it as part of your, quite a few. Oh, most of you, which is great, I love it. So yeah, just for those who are not familiar with infrastructure as code, so you have your application. Now you need resources to run your application. There are other resources in the cloud that your application might use, like blobs, to store blobs, maybe like an S3, the secrets manager where you store your sensitive information, IAM entities for users and roles. So there are a bunch of other resources that go with that. So one way of deploying this is basically going into AWS console and creating this environment every time you want to create, and clicking through buttons and spinning up resources and waiting for it and making sure, or just praying that every time I do it, I follow the steps and then I'm creating them consistently, right? That's not what you want to do though. That's where infrastructure as code comes into the picture. It's a crucial piece of your DevOps methodology, right? So basically what it is modeling all of the infrastructure that you need to run your applications using code. That's as simple as that. By doing so, you gain a very specific set of benefits that directly relate into your team's productivity. So that's what we are talking about, right? How do we improve productivity? The benefits basically are around, you gain the ability to deploy your environments consistently, so you can build and tear down cloud environments as frequently as you want, and the results are going to be consistently the same, right? Because you're creating these environments through code. You're treating infrastructure as code, basically, so you're committing this code into a source control, you are code reviewing your infrastructure as code with the same rigor as you would code review your application code, so it would result in less issues when you eventually go to deploy it. You're also making this part of your DevOps pipeline, so you're using automated provision through DevOps, right? So you gain speed. And finally, you gain visibility because it's part of your code repo. So there are things you could go back and always check how your infrastructure evolved over time, right? So how it evolved, how it looked like previously. So those are your benefits. We said it's always using the good practices and also the right tooling. So let's look at the tooling that we have available, right? First, I want to talk about the cloud native, AWS cloud native tooling that's available for you. AWS CloudFormation is a service that lets you define and deploy your infrastructure using declarative statements like JSON or YAML. There is AWS Serverless Application Model, AWS SAM. This is basically an extension of AWS CloudFormation, but it's specifically useful if you're developing serverless applications. For example, it's very common to host a .NET Web API on AWS Lambda, fronted by something like Amazon API Gateway that lets you manage APIs at scale. And it's using like NoSQL serverless database like Amazon DynamoDB, right? So that's a pretty typical use case. But this use case also is built 100% using AWS serverless services. So when you use SAM, it lets you define the entire stack using only a few lines of code. It has other benefits too. Like it lets you test, debug, monitor your Lambda functions locally by providing you with an environment that lets you do it. Then there's AWS CloudFormation Kit. So this is also one of my favorite because I have a developer background, right? So it lets you model your infrastructure as code, but it lets you use familiar programming languages, higher level programming languages like C#, right, in this context. It also has a bunch of other benefits. I'm going to dig into it a little bit deeper in a second, but I want to talk about the options you have outside of AWS, right? Terraform is a very popular IAC solution, and a lot of my customers that I talk to use Terraform as their infrastructure as code solution, which is perfectly fine because AWS has a provider in Terraform that you could use to model your infrastructure. So these are self-contained, tested modules to model AWS infrastructure using HashiCorp language in Terraform. So the AWS provider has over 1 billion downloads, and it has 2,000 active contributors. So it's pretty evolved. The other option, Pulumi, it's very similar to AWS Cloud Development Kit in that it lets you model your infrastructure using higher-level programming languages, right? And there's a similar AWS provider for Pulumi that you could leverage if you have existing investments in Pulumi, or if your team is comfortable developing in Pulumi, you could continue using it and use the AWS provider for it. With so many tools, again, the question is how do you choose, right? So if you're part of the operations team and you love the simplicity of and the flexibility of using JSON or YAML, those would be your go-tos. Use AWS CloudFormation or Terraform. If you're part of the development team and are actively developing serverless applications, or you're developing, you want to model your infrastructure using a familiar programming language. So those are your options. Use AWS SAM, AWS Cloud Development Kit, or Pulumi. All right, so let's dig a little deeper into AWS CDK. Again, this is one of my favorite because of the reasons that you're going to see. You can model your infrastructure using C#. So you do not have to learn a new language if you're not comfortable coding in anything else. As a .NET developer, I was one of those. You can continue to leverage C#. You don't have to context switch. You can continue using Visual Studio. Don't have to leave it. You also get to use all the native Visual Studio features like IntelliSense, inline documentation. When you use it, it provides you smart defaults. We're going to look at it in a second. So every resource that you spin up in cloud has tens of properties that are attached to it. If it lets you, it doesn't force you to select each of those properties for you to spin up a resource, right? So it provides smart defaults. Obviously, you have the right to override some of those smart defaults. You can also create reusable constructs that you could distribute within your company to make sure that environments that are using particular resources are consistently being deployed in a particular way. And another big benefit is you get a compile time error detection. So you don't have to wait until you deploy it to find out that something is broken. Also remember that C# is only one of the languages that is supported by CDK, right? So if a lot of companies, a lot of customers that I work with, it's common to have polyglot environments where there are teams working with different languages that they're comfortable with. So remember that it also supports JavaScript, TypeScript, Python, Go, and a bunch of other languages there. So you could use this interchangeably with any language of your choice. So now you model your infrastructure as code, right? But if you have to deploy that infrastructure as code every single time you want to build a different environment, it's beating the purpose, right? So what you want to do is make it part of your build pipeline. So build it on demand. So if you want to update your environment, all you need to do is make an update to the code, push it to your SCM, and then make sure your build pipeline kicks in and updates those your environments, right? So and the way you do it is make it part of your code. And the build step is optional. So AWS CDK is a service that gets synthesized once you write your CDK projects to CloudFormation. So that's an optional step. So if you're using CDK, you would build your CDK to CloudFormation. If you're using CloudFormation, you would directly deploy it using AWS CloudFormation. All right, so let's see some of that in action. So what I have here is a simple CDK application. Right? So there are three definitions I want to walk through. So this is a CDK application. It's basically a container of one or more stacks. Right? So let's define a stack. So I have a single stack in my CDK app. It's called IAC demo stack. So stack is a unit of deployment in CDK. So it contains all the resources that get deployed are updated as a single unit. So within each stack, what I have is one or more constructs. So construct is a cloud component that makes up a bunch of components, a bunch of constructs would make up your stack. Right? So this simple CDK application, in fact, this is an application that ships as a template with CDK CLI. right, is creating an Amazon SQS queue, which is a managed queue service on Amazon. It's like 3 lines of code. It provides tens of smart defaults, right? So, and it also lets me override the smart defaults. In this case, I want to change the visibility timeout to 150 seconds. So I'm also able to create an SNS topic, which is basically a managed PubSub on Amazon, with a single line of code. And then another line that basically is adding a subscription of the queue to the topic. I want to show you how easy it is to add new code. So, and also leverage the inline documentation and IntelliSense that comes with Visual Studio. What I want to do is create a user, IAM user in this case, right? So as you can see, I get to use the IntelliSense and inline documentation. I want to name my user. This is the ID that's being used within the construct. Simple like that. Another line of code to basically say, I want to give my SNS topic grant public permissions for the user. Right? That's simple. 2 lines of code. You created an IAM user and also gave permissions for that user to go publish messages to your SNS topic. Now, what you want to do naturally next is CDK gets synthesized to CloudFormation. And the way you would do it is use CDK CLI. Like in this case, I would go and do CDK synth in the project directory. I don't want to do that now because it's going to take a couple of minutes. I've pre-synthesized that into CloudFormation, right? So before my modifications. Now, you can see that 23 lines of CDK code actually translates to 350 lines of JSON code. So you kind of understand the verbosity that's provided by CDK. All right, so again, like we said, having just coding your infrastructure using C# is not good enough, right? So you need a build pipeline that will take the changes that you update your code with and then go deploy them to your cloud environments. So I have a simple code pipeline here, right? So code pipeline, again, is orchestrating all of those stages in my CI pipeline. So I have 3 stages in my code pipeline. One is my infrastructure code, the CDK project, which is in a AWS code commit Git repo. I have an AWS code build, which is my build stage. So it's going to take that CDK project, it synthesizes it to CloudFormation, and hands it over to the next stage, which is my deployment of infrastructure, which is basically taking that and then deploying it using AWS CloudFormation service. So every time I make a change to my code, in this case, I did update my stack. I added new user and changed some permissions. Let's save my code. Git status. Add simplicity. Let's just add everything. Yeah, I just commit my infrastructure code. And then push my changes to the origin. Also, while this gets pushed out, I wanted to walk through how AWS code build works. So it's a managed build service, right? So it looks at a specific file in your .NET repo. The name of the file should be buildspec.yaml. And it looks for instructions on how to build your code. So especially around 2 commands, CDK synth is what is taking your C# code and building it into CloudFormation. It's also spitting out the CloudFormation template that the next stage uses to deploy your infrastructure. All right, let's go back and see if my changes that I pushed to kicked my pipeline. So there it is. So there it is. It kicked off my pipeline, and it's currently building. It's going to deploy my changes to CloudFormation. So it should be as simple as that, right? Hopefully that makes sense.
Yes. No, which brings us to the end of the story, because we show you all the pieces, but let's see it all together. Here we have a project. This project might look similar to some of you. Those are 2 services deployed on AWS ECS. And it's .NET 6. And here we have the source for the inventory service. a plain old AWS ASP.NET service, and nearby, or side by side, we have the tests. We have unit tests, a bunch of unit tests here, and we also have service level tests here. Integration was not something we needed here, nor end-to-end tests. And we have 2 services, as I said, and that's nice, but that's not the important part. The important part is that I have the infrastructure side by side with those services. Now, according to your team, your project, your company, you might have different services in the same repository, monorepo, or different repositories per service. Those rules still apply. You want the infrastructure relating to your service here. You might have a common infrastructure somewhere else, but everything that has something to do with those services need to come with them, because tomorrow when I change the infrastructure, add another service, or change something about how my services should work, I want to do that in the same solution. And yeah, the infrastructure in my case is CDK, because we like C#. And we can say I'm creating a VPC, networking. If you ever started a VPC in AWS, you know that it's not 2 lines of code. And again, CDK has a lot of nice defaults. I just care about 2 IZs. I'll get public and private subnets and NAT gateways and everything I need. If I want something else, I need to define it. But the default is pretty good for me. And this line is a ECS cluster. Again, 4 lines of code. And next, I'm building those 2 services, Fargate service. It's called inventory. You can find the code over there. And all my infrastructure now comes along with my code. And it can be with Terraform and any other infrastructure as code. But this being a development session, we wanted to show you code. But that's not the end of it, because code build and code pipeline are also AWS services, which means I can write them using CDK. I can write my own pipeline in C# with CDK and deploy that. In fact, the pipeline that I showed you in the beginning of the session, this is exactly how you define it. It's not as simple as VPC and EC2, but it's not as complex. I have a pipeline. It would build its own definition from scratch. That's what we see here. It's .NET code building CDK in .NET code, which is kind of recursive. And then we go and define a few tests and the testing stage and our services, and we're done. And we get all the niceness of a CI/CD pipeline baked into our code. So everything should come together, and everything should sit side by side, and that's the way that we can really move forward faster, because if I need to change anything in my code, the build pipeline, my infrastructure, or my services, I can do it in the same place, deploy it, and immediately see it deployed and executed in the cloud. And that is essentially how you do it and how you can move faster with all of those practices and all of those tools and do more with less developers. Thank you for attending this session. By the way, we have a lot of other .NET related sessions. If you're interested, look it up in the application. And please don't forget to give us feedback. We do have time for 1 or 2 questions if you have any question right now, or you can see us in the hall. We'll be sticking around to answer any question you have on this topic or others.